So what would the next row be? Well, like I said, like what would go here? What would go here? Kind of thing, if you like our
6 and 15.
6 and 15. And then you would see like the middle would be 10 and 10, so that would be 20. And then it kind of repeats, like 10 and 5 is 15, 5 and 1 is also 6. And honestly, I might just do one more row. I'm not going to fill out this whole thing because we're going to get quite big numbers, and we're going to see we don't need like our Pascal triangle to be humongous. And if you like ever like, because I will ask you, like we're going to be using Pascal's triangle later. If you ever like forget it, like you could always just Google Pascal's triangle, like it'll come up right away, like with it filled out. So I'm going to stop here. I mean, you're welcome if you want to keep filling this out, but for the purpose of what we're actually using Pascal's triangle, we won't need anything further than this, probably not even as far as we go. So one thing I'm going to kind of label our Pascal triangle is like we kind of label the rows. Like our top row is really if n equals 0, and I'll explain what I mean by n. Like our second row is if n equals 1. So basically you count your rows, but you start with 0. So that's how we kind of label our rows, and I'll kind of explain like when we get to our next problem. So I'm going to see, oh, I can't cut it. Shoot. Is there any way I can like I don't want that. I guess I can cut it without, because I'm probably going to want to reference this, so I don't have to maybe keep scrolling up and down. Let me just copy this. It won't have like the boxes, but it should still be fine. All right, so how are we going to use Pascal's triangle? Usually I kind of have students kind of try and discover this, but I'm going to just try and show you how to use it and then see if it starts to click or not. So let me know. I believe I'm recording still, right? Yeah, okay, I am. So, and if you don't have this printed out, you might want to take a picture actually of what I have on my screen, so you kind of have this Pascal triangle handy. And oops, this should have been a 7 there. I kind of didn't write that, but if you want to take a picture of this so you kind of have it on hand, if you don't have like if you're not writing it down right now, or if you didn't write it down. So like I said, basically our goal for today is we're going to use this Pascal triangle to let us expand binomial expressions. Like if we have x plus 2 up to the 7th power, like how can we expand that out without having to FOIL it like 20 times and hating our lives? So this binomial theorem is going to be quite useful, and it could save you a ton of times, like in terms of if you did have to do some of this by hand, for example. So sorry, and there's some blank pages if you did print this out. So I'm going to kind of show you. Usually I kind of have students work this out, but basically, and let's see, like if I can paste this, we'll see kind of how this. Okay, so I'm going to kind of just put this kind of over here on the side so we kind of can reference that Pascal triangle. But basically, anytime you have a binomial up to 0, like, was it not? Oh, there it goes. Is it not letting me write? Okay, there it goes. Remember, anything up to the 0 power is 1. So it doesn't matter what you had on the inside, if it was 2 plus 3 or 5 minus 2, like it doesn't matter what you get. Anything up to the 0 power is 1. And if you kind of look, if you look at the top row of our table, if your power is 0, you just get 1. And we're going to see it's not exactly like, but it's based on these rows. Let me see. All right, our next one, I mean, x plus y up to the 1st power is just going to be x plus y. But if you look, like what I want you to kind of see, if you look at our table, notice like the coefficients, oops. I mean, n equals 0 is kind of a weird case, but if our power is 1, like notice the coefficients, I know we didn't really write them here, but the coefficients of what we have are 1 and 1. X plus y, if I'm going to FOIL this one, I'm going to do this the long way, and then I'm going to try and show you how to kind of use this for higher powers. That's what my goal is. But if you FOILed this out, you would get x squared plus xy plus yx, or really it would also be xy. Remember, multiplication, you can switch the order, plus y squared. So if I kind of combine like terms, like if you would get 2xy. So if you notice, like that would be our second power, so that would be our n equals 2 row. Notice our coefficients are based on what we got in our Pascal triangle. Like we have a 1, a 2, and a 1. Like, so notice from like the Pascal's triangle, it's basically giving you your coefficients of each piece, if that kind of makes sense. So so here's how I want to so I'm going to show you kind of basically how to do it for a higher power, like, because we could FOIL that x plus y 3 times, but no one has time, or no one wants to do that. So here's kind of like how we're going to do this. So first off, like, so here's how I like to set it up. And I have a video I'm going to show, and we're going to kind of ask a bunch of questions and just yell at me if when this doesn't make sense. Okay. So the first thing I'm going to look like when we're trying to expand a binomial is look at your power. So like in this problem, it's a 3. So we're going to go to the 3rd row in our Pascal triangle. Remember, like when you look at your rows, you start with 0. So it's actually like the 4th row down for the n equals 3. So we're looking at this row here because that's my power, right? So I usually like, it already isn't making sense. Okay. But so I like to just write my coefficients. So I'm going to have a 1, and you're going to put 2 sets of blank parentheses. And then you're going to have a 3, and you're going to have 2 blank sets of parentheses. And then you're going to have another 3, 2 sets of blank parentheses. Okay, I got to write this smaller. So let me rewrite that, but smaller. So you have like your 1, 2 sets of parentheses. You have a 3, 2 sets of parentheses. You have a 3, 2 sets of parentheses, and you have a 1, 2 sets of parentheses. All right, so okay, bear with me here. So you use your Pascal triangle to get these numbers that go in front, and you're going to put 2 sets of parentheses. Here's what we're going to do next. Your first part of this we call our A, and the second part of your binomial we call our B. So in these parentheses, you're going to put your A and B in them. So we're going to have an X and a Y, like in all of these. And what you put inside these parentheses will be the same for like all of these groups you have. Okay, and here's where I'm gonna, like, I'm already losing you guys, and you're probably gonna be like, well, Swift, this is just ridiculous. Okay, so here's the next part. You have to put exponents above each one of these parentheses. So you always start with your degree. So your x part's going to start with a 3. Your y part's going to start with a 0. One tip, your powers should always add up to what you started with. So like all of these pairs of powers we're going to have are always going to add up to 3. So as we do the powers for our next part, the first part goes down by 1. So that 3 goes down to a 2, and the 0 is going to go up by 1. And we're going to keep this pattern going. Like our first power, we're going to go down by 1. The second power, we're going to go up by 1. So the next powers would be the 2 is going to change to a 1, and that 1 is going to change to a 2. And then we continue this pattern. The first power is going to go down by 1, so it would be a 0. And then our y power is going to go up by 1. It would be a 3. But if you look at all of these combinations of powers, they always add up to 3. So I mean, if you kind of notice something's off with that, you can catch that. One tip, if you have a plus sign in the middle, you're always going to have pluses here. If you have a minus, I'll show you. But basically, if you have a minus, it alternates your signs. But now we just need to clean this up. So this first part, I mean, if you clean this up, I mean, x up to the third power would just be x cubed. The y part basically would go away because y up to the 0 is just 1, right? So that's it for our first part. Now we're going to clean up the second part. Well, I mean, this would just be 3x squared y. This part here, if you clean it up, would just be 3xy squared. And then our last part, you're going to notice the x would basically disappear because it's up to the 0 power. And we would just have a y up to the third power. So this is basically a way instead, like, I mean, I know this is probably like, you're still like, I don't know what the hell just happened. I'm not following this at all. But once we get this down, trust me, this is better than having to FOIL this out. Like, instead of multiplying this out, this will save you a lot of time. Because, I mean, you'd have to FOIL this group out and then take that answer and FOIL it to this. Like, this should be easier. All right, so I'm going to start fresh. I want to look at another one, but I'm laughing at what you're putting, Michaela, because you're probably right. All right. So let's look at this fourth one, and I'm probably going to skip the fifth power one because I write way too big. It's already going to be a struggle for me to fit this next one, so I'm probably going to just skip this box here, to be honest with y'all. Oh, all right. So it seems like you guys are loving this already. All right. So like for the problem I just did, if I don't know if you're talking about like the 3 here, basically, yeah, you're just multiplying what you get for those x and y's. This is always like a tough thing, but oh, I don't want to delete everything. But usually it starts to click. It's definitely tougher being online, but usually this is something it usually starts to click by the time we're done. But with us being online and less time and stuff, we'll kind of see if that's true or not. All right, but let's start fresh. Let's just look at another problem. So this x plus y up to the fourth power. Well, we're looking at our fourth row. So if you look, like those are going to be our coefficients. So I'm going to have, we'll see if I can squeeze this in or not. I write way too big. So you're going to have a 1, 2 sets of parentheses. You're going to have a 4, 2 sets of parentheses. You're going to have a 6, 2 sets of parentheses, a 4, and then you're going to have a 1 and 2 sets of parentheses. Right, too big. so we'll talk about this some more, but you basically, what goes inside your parentheses, it's like your a and your b, basically what 2 parts of your binomial, like, so your first part always goes in your first parentheses and the second part of your binomial always goes in the second part of your parentheses. So like all these parentheses are going to be x, y. And since this is a plus, all these are going to have plus signs like between these numbers. So with your powers, your first, like your x power, like your first parentheses always starts the same, and your y power always starts as a 0. And for your powers, like your either your one that starts with like your high one gets smaller each time, and your power that starts as a 0 gets bigger each time. So like this one would be x to the third because it went down by 1, and your y would go up to the first power because it went up by 1. Basically, you're subtracting 1 from your power and adding it to the other power, if that makes sense. So what would our power, like, just to see, like, what would our powers for this next part be? Like, what would the power of my x part be, and what would the x 2, exactly 2 and 2, right? Because the third power goes down by 1, and then the y power goes up by 1. And then you kind of keep this pattern going. My x's would go down again. So that's now going to be up to the first power. And then the y would be up to the third. And then the x would be down to the 0, and my y would be up to the fourth. And I'm sorry, I ran out of space. So this end part looks really ridiculous. So now we just want to clean this up though. So, I mean, anytime you have y to a 0, basically it just goes, anytime you have something up to a 0 power, it basically goes away or it turns into a 1. So, I mean, this first part would just turn into an x to the 4th. This part here, I mean, there's really not too much to do. That would just be 4x to the 3rd y. This next part would be 6x squared, y squared. Like, there's not a ton to simplify. We'll see sometimes they can be a little bit worse. This next part would be 4x y to the 3rd. And I know this is really sloppy, but that x part's up to a 0. So you just have the y up to the 4th at the end. And that would be your answer. Like, so, so let me know if it's any better now. But I want to look at some problems, like if it's just not like x and y, like what if you have coefficients? Because that's the only other thing I could see maybe messing us up a bit with these. So I want to look at a couple more, and then I was gonna either play a YouTube video or just like post a link. I posted on Google Classroom, but there's like a video. This lady does a really good job. This video helped at least some of my students last year. So she's got like I think she's like got a Boston accent. She's got a weird accent. All right, so I'm not seeing too much in the chat, good or bad. I'm gonna repaste my. Why did it? Before it was like perfect. Here, let me see. Can I just cut this again? Why did it work so well before? Let me just try from the original. So, because I want that Pascal triangle handy. All right, now we're in business. Okay. I will try and post some. I wasn't going to post like an assignment that you have to do because I feel like I'm trying to like not overload you guys too much, but there will be some like I'll make sure I mean there'll definitely be like some questions like this on your review for your test. There's not going to be a ton of questions like these, maybe like one or two. Just so you're aware. We'll see how it goes. If it's like complete nightmare, I'm not trying to, but I promise that like once you get this down, this is usually not like a bad part of our quiz. Most people, at least from years past, I mean, I've only taught this class. This is my 3rd year teaching it, but usually this isn't something from years past. Usually this is something that like if I do a good job, this shouldn't be something that gives you a lot of trouble. So when you do this problem, like I said, like you want to write down what your a and your b is. So in this problem, our a is our x and our b is our -2. Basically, like that's what you're going to put inside your parentheses when you write it. So since this is a 4th power, we're looking at this 4th row. Remember though, when you label your rows, it starts with 0. So it's actually like the 5th row down when it's a 4th power. So we're going to write those coefficients. And you always put 2 parentheses between them, like, I mean, after them. Okay. So like I said, you're going to put your a and b in each one of these parentheses. So it'd be like x and -2. Basically, it's like the first part and the second part of your binomial. And then when you do your powers, your x starts, like your first parenthesis starts with like the high power, like what you started with. Your second set of parentheses starts with like your 0. And then your 4 like would go down by 1, like each time. And then your second parentheses, each power would go up by 1 each time. Wait a minute, that would be a 3. So for this, we got to be a little bit careful when we're cleaning this up. One tip, you would see when you work it out, but one tip, when you have a minus signs, your signs are basically going to alternate. But here, we'll just work it out and show you. So this one, if you work this out, I mean, -2 up to the 0 power is just going to be 1. So this would just simplify to x to the 4th. This problem, so this is a little bit different than, because we don't just have variables. -2 up to the 1st power, this would really be 4x to the 3rd times -2. So if you simplify this all the way, you're going to get a -8x to the 3rd. Because that -2 times the 4 in front would give you that -8 or -8. For our next part, if you clean this up, -2 up to the 2nd power, that's going to be +4. So you'd have 6x squared times 4. So if you work that out, that would be 24x squared. And then this one, if you clean this up, -2 up to the 3rd power, that's going to be -8. So if you clean that up, that would be -32x. And then, I know this is a little bit sloppy. Basically, your x part would go away. You would just have -2 up to the 4th power. So -2 times -2 times -2 times -2, that would be 4 times 4, that would be +16. And that would be your answer. But one tip, like if it's a subtraction, you're going to see that your signs basically alternate. But I mean, if you just simplify, I mean, you should see that regardless. Okay, not seeing anything in the chat, so I don't know if it's starting to click or if we're just like, our brain has melted and we're just like done with math. We're retiring. This next problem is going to be like, if this next problem, I mean, if it's been making sense at all, but if this next problem makes sense, you could do anything I could throw at you. Oh, can I explain the power of 0? Sorry about that. I just saw that message. That was from a bit ago. Anywhere you see a power of 0, like remember, if you put like 2 up to the 0 power in your calculator, that's just 1. So basically anywhere in this process, when you have something up to the 0 power, basically it just disappears, because that's really just going to turn into a 1. Like, so this is really like that. This was really 1x to the 4th times 1, if that makes sense. Okay, but let's look at this last one. If we can do this last one, we are golden. So first off, like our a is 3x, like our first part is the 3x, our second part is once again -2. So we're looking at this 5th row. So unfortunately, we're going to have quite a bit to look at. So we're going to have 1, 2 sets of parentheses. We're going to have a 5. We're going to have a 10. Yeah, I should write smaller. Wait, did I skip something? 1, 5. Oh, there's 2 10s. Okay, I'm just going to bring this last one down because I write too big. So like I said, you're going to fill in your parentheses with your a and b. So 3x and -2. And this one, we're going to have to be careful with both parts when we're simplifying. So remember, your first parentheses, you start with like the original power, and it's going to go down each time. And then your second one starts as 0, and it goes up a power each time. So this is it. We just need to kind of clean this up. Hopefully the setup process is getting a little bit better, if you're starting to kind of see how we're setting these up. But really, we just need to clean these all up. So one thing you got to be really careful about is if you have a coefficient with your variable, you got to take that coefficient up to the power as well. So like, and it might be especially like a problem like this, it might be nice if you have a calculator handy. But 3 up to the 5th power, and some of these get quite big. because you're dealing with powers and stuff, but 3 up to the 5th power is 243. So this would be 243x to the 5th. This one, if we start working it out, I mean, the 5 is going to just come down, the -2. But if you clean that one up, that would be 3 up to the 4th. So that's 81 x to the 4th. But then you still got to multiply all of these coefficients together. So 5 times 81 times -2. That would be minus 800. Oops, not the highlighter. That would be minus 810 x to the 4th. So you can see these numbers are getting quite big. Then we need to clean this up. So you'd have 10, 3 up to the 3rd power is 27. And then -2 up to the 2nd power would be 4. So then multiply all your coefficients. So that would be 1080 x cubed. But you should notice like your degree goes down, like if you do have a variable. All right, this part here we have 10, 3 squared would be 9x squared. -2 up to the 3rd power would be -8. So 10 times 9 times -8 would be minus 720 x squared. I'm running a little bit out of space, but this part here, you would have 5, 3x to the 1st, that would just be 3x. -2 up to the 4th power, if you work that out, that's going to be positive 16. So 5 times 3 times 16 would be 240. So I'm running out of space, so plus 240x. And then our last spot, I know this is a nightmare, I'm sorry, this is sloppy. But that 3x part up to the 0 basically disappears. So you would just have -2 up to the 5th power. So that would be a that would actually be a negative. So minus 32. So this would be our answer. But you do need to be really, really, like, that's one thing I want to make sure that's clear. You got to be really careful. If you have a coefficient, when you take it up to the power, you got to take the coefficient up to that power as well. So like that's why, like in this problem, 3 up to the 5th power gave me that 243x to the 3rd. And I mean, this was really just 1. So it's hard to, so I'm going to stop my